Okay, molecular view of elements and compounds. So we've talked about divisions of matter. We talked about pure substances and mixtures, right? So now we're going to focus on the pure substances. Those are divided into elements and compounds. And now we're going to take that and divide it further. Elements can be either atomic or molecular, and compounds can be molecular or ionic. So we're going to talk about each of those distinctions. So elements can be atomic or molecular. Atomic elements are those that occur in nature with single atoms as their basic units, and most elements fall into this category. Excuse me. Molecular elements exist as molecules when they're free elements in nature. And the ones that you need to know about exist as diatomic molecules. That prefix di means two. Diatomic, two atoms. So these are molecules that have two atoms in them. So these are the elements that form diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So oxygen, the oxygen in the air is present as oxygen molecules, O2 molecules, not present as individual oxygen atoms. There's also a significant amount of nitrogen in the air, and that's also present as diatomic molecules. All of these elements, if you find them alone, they will be diatomic elements. I think of these elements as being a lot like junior high girls. I remember being at a rally when I was a junior high girl, and the speaker pointed out that junior high girls never go to the restroom by themselves. They always take a friend. And women kind of carry that out as adults too. You're in a restaurant and you probably take a friend with you when you go to the bathroom. Oh, I need to use the restroom. Oh, I'll come with you, right? And then you do stuff in the bathroom. They don't go anywhere by themselves. So these elements, you're not going to find one atom just out in nature. They don't like it. There's a scientific reason, but I think thinking of them as junior high girls is easier to remember. They're always going to be with a friend. Okay, so these 7 illustrations of this. So this is mercury. Mercury is really cool. It's a liquid at room temperature, but it's a metal. If we zoom in, we see that these are individual mercury atoms in this liquid. Here's chlorine gas. If you zoom in to this chlorine gas, what you see is not individual chlorine atoms, but you see chlorine molecules. 2 atoms hanging out together. Now, it's a buddy system, right? Go to Disneyland, let the kids loose. Buddy system, you got to stay with your buddy, right? So we need to remember those 7. So a couple ways. You could use a silly sentence. They call these mnemonics, where the first letter or 2 of each of these words signifies something. Horses need oats for clear brown eyes. The eyes is a bit of a stretch, but it's okay. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If you see one of those elements, like in a chemical formula, a chemical equation, it's diatomic. It'll be that with a 2 after it. Another way you can do it is to look at the periodic table. There's 7 of them. If you start at element number 7 and draw a 7, you'll hit 6 of them. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Where's hydrogen? He's over here, being the little brother and just not going around with everybody else. Okay, so however it makes sense to you to remember those are the diatomic elements. Compounds. Compounds can be molecular or ionic. So molecular compounds are formed from 2 or more nonmetals. So if you just have nonmetals in the compound, and we know how to identify those now, they're on the right side of that stair-step line. If it's nonmetals, it's a molecular compound. In an ionic compound, you're going to have ions, hence the name ionic compound. You're going to have cations and anions. You're going to have, usually this is going to contain a metal. Not always, but in this class about 98% of the time. It's a metal and a nonmetal. Okay? Examples here, we've got sodium chloride. This has sodium ions and chloride ions in it, a metal and a nonmetal. Here's solid carbon dioxide, dry ice. These molecules have carbon and oxygen. They form actual molecules instead of just being an array of ions that are attracted to each other. Two nonmetals, molecular, metal and nonmetal, ionic. So, compound composed of a metal and a nonmetal is considered ionic. The basic unit of the ionic compound is a formula unit. Ionic compounds don't have molecules. They're a little bit like a magnetic building toy, where you've got the magnetic pieces and they stick together and you can just keep sticking them together. The opposite charges of the ions attract each other, much like magnets do. And so you've got a positive ion and a negative ion. Let's draw some pictures. So there's a positive ion. Let's try to draw better pictures. That's pretty lame. So we've got a positive ion and a negative ion. And a positive ion and a negative ion. A positive ion. And they can just keep going like that. And they'll go in 3 dimensions. So this negative ion, there's room for a positive ion to stick in here, and there's another one over there, and then a negative ion would go in here. And they're going to arrange in a way that's going to maximize the attractions and minimize the repulsions. Because this positive ion wants to stay away from that positive ion. They repel each other, but this positive ion, the positive ion is very attracted to the negative ion. So it's like a magnetic building toy. There's not really a molecule, right? It just kind of goes on and on for the whole size of the thing. There's no molecule. And so we can't really have a formula that tells us how many atoms of each element are in a molecule. There's no molecule. So what we do is an empirical formula. We just look at the ratio of cations to anions. Sometimes it's 1 to 1, or 1 to 2, or 3 to 2. There's all kinds of different arrangements. So we're working up to something called nomenclature, which is learning how to name compounds and write formulas for compounds. And this is the first step. We need to be able to look at elements in compounds and identify, is this ionic? Is it molecular? If it's an element, is it diatomic or not? So let's practice here. We're supposed to classify each as an atomic element, a molecular compound, or an ionic compound. So first look at it and say, well, is it an element or a compound? So chlorine, element or compound? Element. So this is an element. Is it atomic or molecular? Is it one of the 7? It's one of the 7. It's the clear in Horses Need Oats for Clear Brown Eyes. This is a molecular element. We would write its formula as Cl2 because it goes around as a molecule of 2 atoms. This is one of my favorite compounds. No! It's all caps, right? It's yelling? Shouting? No! NO. Is it an element or a compound? It's a compound. Okay, so at a very basic level, you can tell it's a compound because it has 2 capital letters. If it had 1 capital letter, it would be an element. But 2 capital letters means there's more than 1 element there. So this is a compound. So I'll write C for compound. Is it ionic or molecular? It's molecular. You need to find nitrogen and oxygen on the periodic table and ask yourselves, are they metals or nonmetals? They're both nonmetals. So this is a molecular compound. How about Au? That's an element. Is it one of the 7? No. So that means it's an atomic element. It's gold, and gold is found as individual atoms in a piece of gold, not diatomic molecules. How about Na2O? Compound or element? Compound. Ionic or molecular? It's ionic. Sodium is a metal. Oxygen is a nonmetal. Sodium being a metal tells me this is an ionic compound. How about this one, CrCl3? Compound or element? Compound. Ionic or molecular? Ionic. When you find chromium on the periodic table, it's on the left side of that stair-step line. It's a metal. If there's a metal in it, it's ionic. There will be a very few ionic compounds that we see that do not have a metal in them, but that's going to be the exception. If there is a metal, it's definitely ionic. Okay, any questions?